The Alpine Fault is particularly special because it's a type of plate boundary where one side is sliding past the other. It's what we call a strike-slip fault. But there's also a component of movement in the other sense. If this is the Earth's surface, one side is moving up. Okay, so the combined movement is like this. And the reason why that is so cool is that it means that rocks which form, say, at 10 or 20 kilometers depth get carried up to the Earth's surface. And we can look, using microscopy and all sorts of other tools, at rocks that were created at, say, 10 kilometers depth, 15 kilometers depth, 20 kilometers depth. But there's nowhere else in the world where you can do this. One of the things we've moved a little further forward with is a program to sample parts of the Alpine Fault by drilling. And one of the big reasons for doing that is that if we drill to 1.5 kilometers, then we can sample materials that in a few hundreds of thousands of years' time will be at the surface, and similarly stuff which is at the surface now would have been at those depths a few 100,000 years ago. So we can get a full picture, including what happens at depth on this particular fault.